Welcome to JCE Connect online learning. Subject Engineering Chemistry, Module 1 Electrochemistry, topic Energy Storage Systems. In this topic, we are going to discuss about battery, components of battery, types of battery, and we are going to discuss about two important batteries. First one, nickel metal hydride battery, and second one, lithium ion battery. This is the schematic representation of a battery showing its four important components, that are anode, cathode, electrolyte and separator. Definition: a battery is a compact device consisting of two or more galvanic cells which are connected either in series or parallel, sometimes both. It stores chemical energy in the form of active materials, and on demand it converts it into electrical energy through the redox reactions. Battery technology has acquired importance in view of development in microelectronics and increased demand for portable gadgets. The trend of miniaturization has been challenged to the battery manufacturers. The basic electrochemical unit in a battery is the galvanic cell. The major components of a battery are described below. The first component is anode, which is also called as negative electrode. Here at anode, electron will be released due to the oxidation reaction that is occurring at anode during the electrochemical process. And here the reaction is indicated in case of metals as M gives m to the power n plus ion, liberating n number of electrons. The second component, which is cathode, is also called as positive electrode. At cathode, electrons are accepted which are liberated at the anode, and the reduction of the active species occurs at the cathode. The reaction is indicated like this: metal in its N plus oxidation state combines with N number of electrons, giving metal M. The third component is electrolyte. It is the active mass in the anode and cathode compartments. It provides the medium for transfer of ions inside the cell between the anode and cathode. A solution of an acid, alkali or salt having high ionic conductivity is commonly used as an electrolyte. The fourth component is the separator. It is used to separate the anode and cathode compartments in a battery to prevent the internal short circuiting. A separator allows transport of ions from anode to cathode and vice versa to maintain the electrical neutrality. It is an electrolytic conductor but an electronic insulator. That means ions can pass through it but not the electrons. Normally, fibrous forms of regenerated cellulose, vinyl polymers, polyolefins, cellophane, and Nephron membranes are used as separators. Classification of batteries. Batteries are classified as primary, secondary, and reserve batteries. What are primary batteries? A battery which cannot be recharged, because in this case the cell reactions are irreversible and they are discarded when the battery has delivered all its electrical energy. Such type of batteries are called as primary batteries. The electrical current available depends on the quantity of active material present in them. They have limited shelf life and are discharged continuously with fairly high efficiencies. Example for such batteries are Leclanche dry battery, zinc air battery, zinc manganese oxide battery, etc. Normally, we use primary batteries in our day-to-day life for TV remotes and wall clocks. Once they are used, we are going to throw them. Now, secondary batteries. A battery which after discharging can be recharged again. Why? Because the cell reactions involved in it are reversible. How we can do that? By passing the electric current through it in the opposite direction to that of the discharge is known as a secondary battery. Secondary batteries, they are also known as rechargeable batteries or accumulators or storage batteries. The charge discharge cycle, which is called as the cycle life, can be repeated several hundred times, and these batteries can be built into giant generators with high capacities. Examples of such batteries are lead storage battery and nickel cadmium battery. Normally, in our day to day life, we are using such batteries in our mobile phones and reserve batteries. In case of reserve batteries, out of the four components that are required to form a battery, one of the component is stored separately and is incorporated into the battery when required. Usually, the electrolyte is stored separately. For example, magnesium batteries are activated by water. Examples of reserve batteries are magnesium silver chloride, magnesium cuprous chloride, and zinc silver oxide batteries. The main advantage of reserve batteries are their long shelf life, their high performance, reliability, and the option of variety of designs possible in these batteries. Reserve batteries use highly active component materials for low temperature performance. They are designed to meet long and environmentally severe storage requirements. Reserve batteries are primarily used to deliver high power for relatively short periods of time in applications such as radio sonars, airborne instrument to send meteorological information back to Earth by radio, then missiles, trajectories, mid-ocean disasters, and crisis in space.